Thanks for watching my video. Today I'm going to discuss Leibniz's theorem for n-derivative. Okay, our statement is that if u and v be two functions of x, okay, possessing derivative of n order, then uvn is equal to u and v plus n c1 and combination 1 u n minus 1 v1 plus n c2 u n minus 2 v2 plus and so on plus and CR UN minus R VR plus and so on plus and CN UVN. So this is our statement. So we are going to prove this. We shall prove this theorem by mathematical induction. Okay, we are going to prove the theorem by mathematical induction. So step 1. So step 1, for n equal to 1 and n equal to 2. Let's check for n equal to 1 and 2. Okay, is it true? Okay, uv 1 means derivative 1 times. So first function to derivative of second function plus second function to derivative of first function. Okay, here let's check. This is true or false? Okay, this one by putting here n equal to 1. Okay, what you get is uv1 is equal to u1v plus 1 combination 1 mean is just 1. So u in place of n in is 1, so 1 minus 1 means 0. We just write u. So v1. So this and these are same thing, isn't it? vu1, this is vu1 plus uv1, this is same thing. Okay, for n equal to 2, let's check. That means we are going to take derivative this one one more times. So from this we have two functions again. So if you take the derivative, first function the derivative of second function plus second function the derivative of first function. Okay, since here we take derivative 1 time already, here it will be 2 times plus, and from this what, first function the derivative of second function plus second function the derivative of first function. So if you simplify u v2 plus, if you see these two are same, so 2 u1 v1 plus v u2. Okay, and similarly if you check here, if you put n equal to 2 here, you'll get the same result. Okay, that means this theorem is true for n equal to 1 and 2. So now step 2. Let's proceed for step 2. In step 2 we should assume the theorem is true for n equal to m. Let's take m. Okay, we assume that it is true for n equal to m. So uv m is equal to, in here if you put n equal to m, okay, you get umv, which means unv, which means we put n equal to m, so umv plus nc1, which is MC1 un minus 1 V1 u m minus 1 V1 plus MC2 u m minus 2 V2 plus and so on plus m cr u m minus r vr plus so on plus mcm u vm. Okay, if you see there, same thing, in place of n we put m. Okay, this same thing. So now we are going to prove for m plus 1. Okay, differentiating both sides. Differentiating both sides, where we get uv m, since we take one derivative one time again, so um plus 1, and in this you get two functions. Okay, in this one, so first function which is um, second function v1 plus second function first function. Okay, this two is from this one plus, and mc1 is just a constant. Okay, it is just a constant, it is just a number, so which means derivative of constant, it can with one function it can come out before the derivative, which is mc1, and in this here I'm going to take the derivative again, so derivative of first function the derivative of second function plus second function the derivative of first function, which is m minus 1 plus 1. Okay, this is minus 1 plus 1, and plus again here mc2 is just a constant. Okay, so it can come out mc2, and in this two you can get first function derivative of second function 3 times, this is 3. Okay, plus second function the derivative of first function m minus 2 plus 1 plus and so on plus again we are going to take the derivative of this one, and before that I'm going to take the derivative of this one before this one, which means r minus 1. Before this one it will be mcr minus 1. Okay, before this one, so and mcr minus 1 will be what, it is constant again, so mcr minus 1, and in here what you get, since r minus 1. Okay, let me elaborate here. We take before this and before this one, it is r minus 1. Here what you get, um minus r, since we take r is r minus 1. Okay, r minus 1, it will be minus minus plus, which is m minus r plus 1. Okay, here also r minus 1 it will be, but in here let's not right here. Okay, okay, before that one, if you take m minus r plus 1, get this first function the derivative of second function r minus 1 plus 1 plus v r minus 1 u m minus r plus 1 plus 1 Okay, before this one mean what? In is u m, what is that? Before this one, m minus r minus 1, which is plus 1, v r minus 1. Okay, if you take the derivative this one, yeah, we get this one, and all these are suffix. Okay, plus, now we are going to take the derivative this one now, plus mcr, just like constant, so we are going to take the derivative this one, which is u first function into second function, okay, plus second function into derivative of first function, plus and so on, plus, and last term mcm. mcm, where is that? Here, first function to derivative of second function, plus, let me write here, okay, this continue, second function to derivative of first function. And in the next paper, I'm going to continue this one. U v m plus 1, m plus 1, which is, now if you check out here, now keeping this one constant, okay, keeping this as constant, one is that u m plus 1 v, u m plus 1 v, plus, and this one, and where is that? This one, because these two will cancel. Okay, minus 1 plus 1 means 0. So um v1, which is um v1. And here what we get is that m combination 0 plus m combination 1 um v1. Because here, if it is not here combination, okay, it will be m combination 0. So I'm taking out the common. Again, you will see this one, and in here, this one can be what? Minus 2 plus 1 means m minus 1. Okay, which means these two are same thing again. Taking out the common one, mc1 plus mc2. Okay, what is that? U m minus 1 v2. Okay, and in here, if you take the next term here, okay, if we have the next term, this and the next term can be taking just like this. So let's put in this, so on, plus, and again in here we can cancel this and this. Okay, and this one can be take common. Okay, this one and this one I can take common, because um minus r plus 1 vr, um minus r plus 1 vr. Okay, this means mcr minus 1 plus mcr, mcr minus 1 plus mcr, and one is the or common one, u m minus r plus 1 vr. Okay, And if we have here one term again, that term and this can be taken and just like this, and in here also this one, and before this one if we can take, okay, so this one taking out, okay, MCM this, so on, MCM, what's that, U V M plus 1, okay. From this, let me put as recall that NCR plus NCR minus 1 is the same as N plus 1 CR, okay. This one we are going to record back because we are going to apply here. This one is same as this one, so UV M plus 1 is U M plus 1 V plus, and in here you get, if you apply this one you get what, M plus 1 C1, okay. And then what is the UM V1 plus, and here also if you apply this one you get M plus 1 C2 U M minus 1 V2, okay, this one, and plus so on, plus in here also if you apply this one same thing, M plus 1 C R U M minus R plus 1 VR, okay, plus so on, plus, and MCM is the same as M plus 1 C M plus 1, okay, which is same thing. If you apply the combination formula, okay, you get the same thing. Okay, we reached already. Now just put M plus 1 is equal to N, okay, in here. So what is that? UV M plus 1 is N, which is equal to UNV, okay, plus NC1 U, and here we have only M, okay, and here M plus 1 we put N, okay. If you find out M here, that means this I will transfer here, that means N minus 1, okay, N minus 1 V1 plus NC2 U, okay. In here we get what, UM minus 1, here M plus 1 is N, so in order to get that one, what, M plus 1, okay, M plus 1 minus 2, which is N minus 2, which means this one, 1 minus 2 means minus 1, so M minus 1 is N minus 2, okay, which is N minus 2 V2 plus so on, plus NC R U, and in here since we put M plus 1 equal to M, okay, here I can take this and this one, M plus 1 minus R, which is what, M plus 1 is N, okay, minus R is left, so VR plus and so on, plus here NCN UVN. So if you see this or last result, okay, with the first result, if you compare here, is it same thing, this one? Yeah, it is same thing. Yeah, isn't it? So we know that it is same, so Hence, by mathematical induction, it is true for n equal to m plus 1 whenever n is equal to m is true. So what I mean is, if n equal to m is true, that means n equal to m plus 1 is also true. Okay, here we get that n equal to m, and this is our last result. And thanks for watching. Please subscribe to my channel for more new video. Thanks.